let me start with agenda. So I'll start with a simple mathematical modeling problem, like say linear algebra from data science point of view. Then we'll get into image pre-processing, just to give you the idea about how to play with linear algebra techniques to solve bigger problems in data science. And then I'll move on to political analysis. Okay. So, and by the way, as almost all of you know about machine learning problems, I mean, heard about machine learning problems. There are three kinds of machine learning problems in general we segregate. One is supervised learning. Okay. And second is unsupervised learning. And third is reinforcement learning. Okay. In supervised learning, predominantly we solve problems of the kind Ax equals to B, where X is unknown set of parameters. Okay. So in supervised learning, we'll be solving like say problems of this kind. And of course, here just for the simplicity, I wrote underlying problem as linear problem, but the problems could be non-linear as well. In unsupervised learning, we predominantly worry about data structure in the given data, how the data is being segregated. Like say, are there any groups? Say, for example, if you take set of patients in a hospital, healthy patients, unhealthy patients, because anyone walking into the hospital, doctors treat them as patients. So healthy patients, unhealthy patients. Can we get some sort of those groups? And say, for example, male, female, like say adults and kids. I'm just giving like say simple examples to say like what could be clusters. And then when you take telecom kind of industry, like customers who are paying more money, customers paying who are paying less money, customers who would be subscribing to more services, customers who may actually go out of the service. I mean the churning. Right? These sort of groups can we identify in the given data. So those sort of techniques you can outside, you can refer it as unsupervised learning. And then there is one very, very important and interesting technique in linear algebra what we study. Have you people heard about something called PCA, principal component analysis? Right? PCA is predominantly used for few reasons in data science. One is to reduce the noise in the data. Okay. And second is to remove collinearity. I mean the dependency on different columns in the data. Okay. Remove collinearity. And third is data reduction, data size reduction. Okay. So these people may call it as data compression as well. Okay. Some people may call it as data compression, data size reduction. Okay. So when we look at PCA, before we apply PCA, the data could be like this. Say, for example, let me write these are number of rows, row 100. And now we have like say columns C1, C2, maybe C50. Once you apply PCA, by holding back 95% of the information in the data, for example, I'm just giving 95% as industry standard, holding back 95% of the data in the information in the data. Okay. Probably I may need to use just few columns, right? Say, for example, let me say C1 tilde, because the new columns will have new names, right? Let me not use 5. Let me say, like say, maybe with 7 new columns, I may be able to express 95% of the data, 95% of the information in the data. So this is old data and this is new data. Okay. So PCA is also used as unsupervised learning technique. I mean, PC is referred as unsupervised learning technique. So now we have like say two kinds of techniques: supervised learning, unsupervised learning, and third is reinforcement learning, which is like a new trend. By the way, it's not a new technique per se, but it is a new trend nowadays in the market. People who know reinforcement learning, they are paid very heavy. Either you can be in academics, but you can actually start working as a consultant, okay? Or if you move to industry directly, reinforcement learning experts get paid heavily compared to regular machine learning experts. And by the way, just to mention some of the names experts in reinforcement learning, since you are in, like say, majority of you know people in Chennai, Mumbai, and Bangalore. So, for example, Professor M.K. Ghosh from IASC, okay, and Professor Malli from IIT Mumbai, okay, and then we have, like say, from Chennai, Professor Saiju, Maths Department, okay, and then you have, like say, Professor Borkar, just retired from IIT Mumbai, okay. These are some of the well-known reinforcement learning experts, but they call themselves as, like say, statistical games experts kind of thing. But from industry point of view, they are seen as reinforcement learning or learning theory experts. Right? Okay. Now moving to our main concept. Let me know touch base on supervised learning. Right? Let me take in supervised learning a simple problem called a linear regression. Okay. And by the way, this is the backbone of data science, linear regression. If you know linear regression, you can actually get into deeper concepts in data science. At the end, everything boils down to linear regression in data science. Okay. Linear regression is a method for modeling the relationship between input scalars and output scalar value. Okay. Say, for example, let me take x1, x2, x3 as input values. Okay. And y1, y2, y3 as output values. And let me call the error as epsilon. The model assumes that the relationship between input and output is a linear function. Okay. So this is how I can model now, right? I have, like say, this is output and this is the input, and by the way, and this is error, right? And if you actually look at the model, I have assumed it as a linear model. I mean linear relationship. I have, like say, unknown parameters here, beta 0 and beta 1. So I basically need to find out how these, like say, what are these beta 0 and beta 1. Once I find out these beta 0, beta 1, I can now get into the forecasting, right? And by the way, and this is a simple linear regression model, and this can be extended, as we all know, very easily to multi-model. I mean, multi-input model. Instead of one input, now I have multiple inputs. Okay. Then I can actually build bigger and bigger models here. Bigger and bigger models in the sense covering a lot of data points. So if I actually showcase it with a simple example, say for example, I have, like say, area of the house and number of bedrooms and the price of the house in lakhs, right? So one house, like say 1.2, I mean 1200 square feet, number of bedrooms 2 and 40 lakhs. Okay. Next house 1.5, I mean 1500 square feet, 2 bedrooms, 55 lakhs. Okay. So we have like the data with us, and what is our input and what is our output? Our input is number of bedrooms and house. Okay. Let me call our input as X. And what is our output? We need to basically get the house price, right? This is Y. So now if I actually look at it, for this given set of input, okay, what is going to be our output? And of course, there will be error, right? And you see, the modeling is very, very important in data science. Unless we model it properly, we may not be able to solve the problem. Okay. Now you see, I have like the underlying value submitted. Okay. Now you see, I am getting it as AX equals to B. Just for time being not writing the error, right? Ax equals to b. Okay, what are our unknowns here? Our unknowns are beta 0, beta 1 and beta 3. Sorry, beta 0, beta 1 and beta 2, right? And now once we solve this problem, and we know like say how to solve this one, once we solve this problem, we can actually get this problem sold to real estate people. I mean the companies in maybe in Bangalore, Chennai kind of thing. And this is what we call it as one of the interesting problems in real estate. And if you want to actually have a real data with this, you can get into a platform called Kaggle. Okay, kaggle.com. So there are good number of data science problems exclusively for real estate, whatever problem I defined just now. Okay, good number of data sets and you can practice there, right? Okay, now we just now touch based on simple linear regression problem, which is a supervised learning problem. Okay, now let us move on to the next concept called like say importance of matrices. Is it okay, friends?
Yeah.
Okay, so importance of matrices. Okay, before we actually get into importance of matrices, let me introduce the importance of matrices from pictures point of view. I mean from images point of view. Computers use discrete form of pictures, right? And so the process of transforming a continuous space, I mean or physical photo to a digital photo is called digitization. Okay, so the steps in digitization are the following. You have like say the physical photo, right? And now in the physical photo you have like say all pixels. I mean in a physical photo you cannot actually separate them and see. You have to basically see the physical photo as it is. So that is continuous space. That's how you can actually look at it. And now from that continuous space to the computer you have to tell like say what and all point to be stored, right? And that's what we are basically calling it as sampling. And then you basically get it as a digital picture. Once you get the sample of points what to be stored, and then you get a digital picture. Digital picture is nothing but some points taken from the continuous form. I mean continuous picture. Say for example, I have my image. Okay, now I'm scanning the image in the scanner. Okay, in this like say process, most of the time you people might have observed what is the quality you want to have in the picture. Okay, this is what by default it will be set, and but you can actually change it. So whether you want to store it as a 2 MB picture or 4 MB picture. Okay, so your system will ask while scanning, as soon as we say like say I want 2 MB picture, so you basically get your picture stored. And if you observe, 2 MB picture quality will be less, clarity will be less, but 4 MB will be better. So when you actually look at the 2 MB picture, the picture will be stored as a set of matrices. Okay, set of matrices as rows and columns. That's it, friends. So pictures are stored as matrices, either 2-dimensional or 3-dimensional. 3-dimensional matrices, let me explain like say going forward. Okay, let me now think about like say image as a 2-dimensional matrix. Is it okay, friends?
Yes.
And now, if you actually observe, whenever you walk into any Photoshop, I mean, you take your old photo and then you actually basically want to clean that photo. Maybe there would be some dust on top of the photo, and now you want to clean it, right? And they open Adobe Photoshop and immediately they start cleaning it, right? And all those are nothing but linear algebra applications. They call it as filters. Filter is nothing but a matrix. That's what I'm going to show you. Okay, so this is like say I'll say this a presentation, just a technical definition I'm giving here. Okay, so just moving ahead, a picture when you actually magnify it from in the system, you actually start getting pixel values one by one. Okay, and you can open it with the notepad and you will see the actual values, I mean the numerical values in the picture. Right? So the numerical values for the picture, okay, each point will be between 0 and 255. 0 is black, okay, 255 is white, okay, and so and any other gray color values lying between this 0 and 255. So there are totally 256 possible values for each data point in a picture, and each data point is referred as a pixel. Okay, each data point in a picture is referred as a pixel, and pixel is an atomic element. For us, pixel is nothing but an integer. Okay, and now if you use like say Python kind of environment, okay, in Python you can actually store it as n-dimensional array. I mean the image can be stored as an n-dimensional array. Okay, I'm just giving you an like say high level view about how an image can be stored. Right? And now when it comes to like say color photos, in general color photos are stored as three two-dimensional matrices. Okay, so one for red and one for green and another for blue. Okay, RGB or BGR. Right. So I have like say red matrix, green matrix, and blue matrix. Okay, so that means for any given color photo, there will be three matrices, and these three matrices put together is referred as a color photo. And these three matrices together, we call it as a three-dimensional matrix. Okay, let me show you how it is in the next slide. So let me take an image. From system point of view, it is seen as 3D matrix. Okay, so red matrix, green matrix, and blue matrix, and all put together, you basically get a value. And if I take any value here, say for example, this is the value in the color photo, and that value when you actually see from system point of view, it will be something like say 255, maybe 4 and 100. Okay, so the red pixel value is 255, the green pixel value is 4, and the blue pixel value is 100. Okay, and that's how a color picture will be shown. And now you see complete image related stuff is nothing but set of pictures, set of matrices, right? And now moving ahead, so let me go to the next slide. I'm taking like say a picture, and you see the pixel value, whatever we are actually looking at, right? It is close to, or let's say some gray color. It has a number, I mean the pixel value between 0 and 255. Another one, okay, third. Right? So 0 is black and 255 is white. Okay, and so any pixel will be lying between these, like say complete black to complete white. So this is how the image is represented in the system. Okay, now going ahead. Okay, color picture is shown like this, right? As I explained earlier, color pixels can be actually having different formats. One is RGB. Okay, this is the dominant format, and then you have like say other formats, but I never used these formats like say lab or HSV, but we have been using RGB or BGR. Okay. Now let me look at image processing, right? So now cleaning the images, whether we want to clean intensity, I mean whether we want to blur the image or like say get magnified some sort of information in the image, or we want to basically stretch the image, okay, spatial or intensity. Okay, so based on the need, we can like say call the respective matrices to work on. Okay, so for example, intensity filtering. So I have the image. Image is represented as a set of numbers or nothing but image is represented as a matrix. And now we apply a filter. okay, on top of this image, and then the resultant image, okay, that would be the one what you expected, whether it is like say cleaning or cleaned image or magnified image or blurred image, right? And all that is nothing but happening through a matrix multiplication and addition, okay. And this is what is like say the intermediate matrix is referred as filter, or from Adobe Photoshop point of view they may even call it as brush. Is it okay, friends? Any questions here? Yeah, okay. Now moving ahead, and of course, when we actually get deeper into the concept, okay, they actually get into some sort of convolution, okay. So matrix point was multiplication and then addition. This is how they basically do it, okay. I'm just giving you an idea like how a filter is applied on a matrix, okay. So there is a concept called kernel. Kernel is nothing but again a matrix, okay. And of course, it will have its own properties. Okay, we impose properties on that one, right? So this is our kernel, right? And part of the input image, and when kernel is applied on the input image, and this is what the output we are getting. Okay, and how the operation is being performed is explained here. Okay, and this process is referred as convolution. And if you actually observe, this is again our basic matrix multiplication, right? But on a slice of the image we are applying. Okay. So if I take this as an image and when I apply kernel on top of it, you see the resultant matrix. Okay. Now coming up with like say meaningful kernels is one of the tasks for scientists, right? So, for example, if I come up with a kernel, it is referred as identity kernel. Okay, the first one. So the input image will not be changed. Okay, and then detecting the edges in the given image. If you actually use this sort of filters, you'll get the edges. And now, if you actually look at it in Adobe Photoshop, this is what people do. Like, say, they apply the filter, they get the edges, and only take the person from the image, okay, and again paint with something else, right? So they are predominantly playing with matrices there. I mean the filters. And if you want to sharpen the given image, okay. By the way, you may ask, let's say, how did we come up with these numbers? And of course, again, you can see like you have ax equals to b kind of thing. I want like say a powerful sharpened image, and what are the points I need to have it in my like say input filter. I mean not the input filter per se, but what are the values I should have it in my filter. Okay, so it is again coming back to something like a linear programming problem, right? So now you have like sharpened image, it like say edge detection in the given image, or like say stronger edge detection. And now you can actually look at like say blurring an image, right? Blurring an image with like say as a matrix transformation, right? So now we are seeing like say linear algebra at work, right? So you being like say learning mathematics or like say practicing mathematics, you see like a huge number of applications, right? Now coming to spatial transformation, so far whatever we discussed about is nothing but intensity transformation, right? Now looking at spatial transformation in the sense like say whether you want to basically have the image or to have a pulled effect or pushed effect, like say contrasted or expanded kind of thing. Okay, so you have like say scaling, rotation, right? And if you actually look at it, scaling, you're using like say some sort of scaling parameters in the diagonal of the given matrix. Rotation, our well-known friends cos and sine, right? Whether you want to have translation in the like say horizontal way or vertical way, right? So you can actually do. the respective translation or rotation for the given image. Okay, and you can have rotation and translation combined, right? And so this is like say a very interesting one, right? And now there is one more thing, right? Whenever you actually perform an operation, and if you don't want that operation to be there, you use control Z. Okay, control Z in the system. Control Z is equal to something like say matrix inverse. Right? You wanted to remove the unwanted effect or whatever you have actually applied. Matrix inverse is like so you can take it as control Z, right? You want to actually remove the earlier effect, right? So say for example, I have an image. Let me say this is an image. I applied a filter on top of the image. Okay, I got image modified. Now, if I apply the filter inverse, because filter is nothing but a matrix, and if I have inverse of that matrix, if I apply that inverse of the matrix on the resultant image, I should get back my old image, right? And this is what like say I can see inverse from this point of view, right? And now another like say the set of applications with the image related stuff, you can look at data augmentation and image annotations. And by the way, let me touch base on what are data augmentations. You people might have seen something called attendance system, right? So auto attendance. So when you walk into a or like say any office, the underlying system, it actually takes your photo and immediately says you are Mr. X, and then your attendance is marked, right? How do they do it? Because you have like say you might have given one or two of your photos, but how do they actually know like when you are seen from a distance, how do you look like? Okay, so from the given photo, okay, from the input photo, it can actually, I mean, the system can generate n number of views for the given photo by using different matrix transformations. And then they can actually, I mean, the system can tell you, like, say, how do you look from distance? How do you look from, like, say, vertical, I mean, slightly rotated view, right? And then the system actually now tells, like, say, when you are walking to the office, whether you are Mr. X or not. And then automatically the attendance is marked in the system. Okay, so from the given image, generating more number of images of viewers, that is referred as augmentation, data augmentation. And this is a very powerful technique, and we actually get it from simple linear algebra applications, right? And similarly, like say image animations and annotations. Okay, we can basically get it from basic like say linear algebra transformations. Okay, and by the way, so we touch based on linear regression, okay, and we touch based on image analytics. Image analytics, like from linear algebra point of view. Okay, now let me get into political analysis. Okay, so what are the use cases for the political analysis? So some of the things like say what we can do in political analysis using mathematics. Point number one, right? I'm going to now refer simple problems to the complex problems in data science from for political analysis. One is there will be a lot of people, like say, a lot of politicians aspiring to be as MLAs and MPs, right? And if you actually look at Uttar Pradesh, which is going for elections in next few months, maybe 4 5 months, they have 403 MLAs in the assembly, right? Out of these 403, 260 MLAs are first timers. Okay. And like you and me, these politicians also want to have a longer career, right? But if you actually look at it, out of 403, if 260 are first timers, that means their shelf life as a politician in power is very limited, right? So one of the problems now you can define as renomination. How many of these 403 MLAs are going to be renominated for 2022 elections? Okay. So unless you perform well, you will not be renominated. But what are the chances of a person getting renominated? And the second problem, renomination and re-election. And by the way, so now you have to get into the probability related like say calculations, and for a given MLA, what are the renomination probability? And for the given MLA, what are the renomination and the re-election for 2022 probabilities? And this is one of the hot cakes in the market. If we can do these things with good accuracy, it is actually very interesting. From party level, renomination in UP related or UP kind of bigger states, the renomination percentage of probability is not even 0.66 for a given person. Not even 0.66 probability he would be renominated, and re-election is not even 0.25. Okay, less than 0.25. Okay, this is first problem. Any questions, friends, here?
So how do you collect these probabilities? Like,
Well, very interesting one. And by the way, if all these problems are driven by data, right? So you basically have to look at a point by point for these things. You see, like last election in UP was 2017, and before that it was 2012, and before that 2007, 2002, 1996. Okay, and then you can actually start going ahead, right? So look at like say at least last 5 elections and see, calculate your probabilities. Okay, for a person, what are the chances of he getting renominated, and what are the characteristics, right? And this actually consumes good amount of time. And with historical data, only you can actually calculate these things. With theoretical probabilities, it will not actually give us any like say relevant results. Is it okay, friends?
yeah, thanks.
And now the second one. Okay. The second one. Now you
Just
have
one
like say,
second. Sorry to interrupt, Narayana.
yes.
Yeah. So roughly, I mean, how many parameters you are looking for the renomination?
Well, so for our algorithm, we are actually looking at around 150 parameters.
Okay, that's quite a lot.
Yeah.
Right.
So,
Okay.
and of course,
Fine. I'm not going to ask which are the parameters. Okay, go ahead.
Yeah, some of the parameters may some of the parameters are at the constancy level, some of the parameters are at candidate level, and some of the parameters are at like say population demography, and final one is at party level. Okay, so the reason is, if you actually look at some of these candidates, have you people heard about a person called Jayesh? She is a film actress and got elected from UP a couple of times as parliamentarian. So she got elected from Rampur, right, parliament seat couple of times, and from like say Samajwadi Party, right? And now after like say Amar Singh dominance came down in Samajwadi Party, so she actually did not get seat in the third time, right? So now how do you basically get that one? Third time she did not get renomination, right, from Samajwadi Party. She had to actually get renominated from somewhere else. Okay, So you need to basically worry about multiple parameters while calculating the renomination and re-election probability. Okay, and then there is one very interesting thing, right? Like in IPL, right? Like in IPL, if a aspiring MLA candidate wants to go for election, right? He wants to like say contest in the election, and we all know, though it is like a sad thing, but we all know contesting in election in most of the states is like say with the real money, big money, right? Before going for the election, can we actually assess the candidate, assess the aspiring candidate about his capability to win the elections? So what we basically work on three vectors. One is acceptability of the candidate by the people, visibility of the candidate in the constituency, and then winnability of the candidate. And by the way, we actually came up with algorithms for this. Now let me give you acceptability. Okay, so if you actually look at uh, three different things. Okay, visibility, if you look at any film personality, they are highly visible to the market, I mean to the constituency people, right? So visible people, like say film personalities or social media celebrities, okay, they come under visible, like say they are highly visible, but they are hardly acceptable. And if you look at like say some of the film actors contested in recent Tamil Nadu and Kerala elections, they did not win, right? Their visibility is very high, but acceptability and winnability is low, right? And if you look at some of these like say business people, their visibility in the media may be less, but their acceptability as a successful person is high by people. Okay, and of course we need to actually come up with our own parameters to calculate that, right? So you can say successful business people, successful business, right? And then you have like say for acceptability, okay, you can think about like Rahul Gandhi. He was not acceptable last time in Amethi, but he was acceptable in Wayanad, right? So he is highly visible, was not acceptable in one constituency, but acceptable in another constituency, right? And his winnability, of course, driven by multiple other factors as well. His winnability is very high, and winnability is low. For someone like say Rahul Gandhi, winnability is very high, acceptability is very high, and visibility, he is always there in the media. And now, if you take our Honorable Prime Minister, his winnability is very high. Winnability from a given constituency, let me take it that way. Visibility is very high, acceptability is very high, right? So we basically need to come up with a quantitative numbers for this. And then you can tell, like say, if I take it as like say between 0 to 100, right? If I take it as 0 to 100, acceptability is say for example 80, visibility is 90, and winnability is 10, right? The candidate, probably he need not go for the election. He can actually wait for some more time, and the next elections he can like say he can contest instead of wasting money, right? So that's what like say using our data science concepts, you can actually get these things. And by the way, visibility, we talked about like say how do we actually look at visibility? You need to find out the person in the media, right? How frequently he is appearing. Media could be text-based media or like say image-based media. And now we have like say we looked at or linear algebra applications, right? Images can be played with like say something like matrices. Now build your underlying system in such a way that you can assess the visibility of the candidate and acceptability. Okay, you basically need to get into the polls, okay, poll of the constituency people, right? And that you have to collect the data both online and offline in a systematic manner and find out like say how acceptable the underlying person is. Okay, and winnability, look at like say his previous history, like say on a person basis, on a constituency basis, and on party basis. Okay, so all this put together, you actually come up with your own algorithm, and then you have like say the number, right? If winnability also is something like say 85 kind of thing, now you see this is idealistic scenario, right? High acceptability, high winnability, and high visibility, right? And then you can say like say the underlying candidate, you can go for election now. Any questions, friends, here? Okay, now the third one, okay, issues identification. Okay, now scan through the media and also get your own assessment from the constituency. Okay, identify the pressing issues using our data science applications. So pressing issues, let me actually tell it as, say, for example, security is one of the pressing issues, right? And then education, maybe like say infrastructure. Okay, so scanning through the media related information and also from the people input, now find out what are the pressing issues. And for this one, you need to basically have very good hold on natural language processing tools. Okay, again, you are getting into something like say playing with matrices and vectors. Okay, and find out the underlying issues. Is it okay, friends? And in this process, by the way, you need to actually clean the data to the greater extent. The reason is in recent times, after Facebook and Twitter came in, there are like say newer and newer like say data points or newer and newer words coined, right? So to handle all those like say newer coin and newer words, you basically need to have your NLP tools properly developed. Okay. Now, what are the importance of these issues identification? Based on properly identified issues, now the candidate, okay, I mean the political candidate, and also the party can focus on the people needs, and then their campaign can be automatically adjusted. Have you people heard about something called Cambridge Analytica? It was in the news for wrong reasons sometime back. Right? Cambridge Analytica was predominantly trying to get the issues identified, and of course, they were doing any number of other things as well. Okay, and trying to gauge the people mood. Okay, so using NLP tools, by the way. And then, have you people heard about something called IPAC? Friends, have you heard about IPAC?
No.
Okay.
Yeah.
Have you heard about something called Prashant Kishore?
What is it?
Prashant Kishore.
Yes.
Okay. Prashant Kishore company is IPAC. Indian Political Action Committee. Okay. And these people do good amount of data analytics. And you know, like say Prashant Kishore, he's a very big brand as far as political consultancy is concerned in India. Right? Political consultancy or political strategy. Right? And he uses good amount of both primary data and secondary data. In the sense, he collects data from the people directly and he uses already existing derived data. Right? IPAC is one of the dominant companies in India providing campaign management, how a candidate has to spend his energy on the ground to win. Okay, let me put it as optimal campaign management using data science techniques. And by the way, recent successes for him, like he actually helped MK Stalin to come into the power in Tamil Nadu, and Mamata Banerjee to come into the power in West Bengal, right? In 2021, right? And in 2019, he worked with Jagan in Andhra, right? And in 2017, he worked with Punjab government. I mean, not Punjab government, with Captain Amarinder Singh. And in 2014, he worked with, like say, NDA. I mean, with Modi ji, right? And in 2017, one of the only failure of Prashant Kishore is, like say, he worked with the Congress in UP in 2017, but that was not a successful one. Right? So now you basically have to look at the kind of services he provides. Let me put it the way, the data science way. The kind of data science problems he focuses on, right? People sentiment, issues identification. Third is optimal campaign management. Okay, and then like say candidate success assessment. Okay, assess a candidate, and then you have like say SWOT analysis in a frequent interval basis. Strengths, weaknesses, opportunities, and threats for a given candidate and the political party. Okay, friends, and when he is actually doing not only Prashant Kishore, when any political strategist is doing this sort of data science activities, we predominantly focus on one of the main thing is linear regression. Linear regression is backbone of any data science activity. And the second thing is, I just touch based on only image related. Okay, so image related analytics, extension of image related analytics, NLP. Okay, and so these are broad level techniques we use to solve this kind of like say problem, sentiment analysis, whether people are like say reacting positively for a particular issue, notebandi, I mean demonetization. How did people feel? What are their sentiments, right? And now you have like say Corona, right? What are the issues people are facing? Identify that. And now candidate has 5 crores to be like say he is planning to spend for his win in the coming elections. How should he spend, and what are the, I mean, what should be the team structure for his campaign management, right? And that I'm referring it as optimal campaign management. And before that, let me assess candidate quantitatively whether he has any chances of winning or not. And now in a frequent like say basis, let me do SWOT analysis.
Hello. Sir, sorry to interrupt, but our time is almost over.
Yeah, I'm done.
Okay.
Okay. And over to you people. Like say any questions, please.
Anyone who is having any doubts, please raise your hands.
So friends, if you actually observe, it looks like non-quantitative field, political analysis, but in the back end, it is purely a data science activity. Okay, that's why I touch base with like say linear regression and image related analytics. And since NLP is slightly a broader field, I did not actually get into that one because I would not be able to do justice in 1 hour talk.
I think Saumyadi is having a doubt.
Yep,
Yeah, hi.
please.
So if someone wants to learn this subject from the very beginning, would you recommend some books or references?
Well, the best way to get into this field is let us do a small project, a 3-month or 4-month project. Okay, it is more practice oriented than theory oriented. So, for example, there is a data set in Kaggle. You have like say last 20 years Times of India headlines. Okay. Take this data set and now let us do kind of analytics, like say, for example, sentiment, issues, party-wise analysis. Okay. When you do this sort of analysis on this bigger data set, 20 years headlines, by the way, it's huge, right? When you do this sort of analysis on the given data, you basically will get hold on the techniques. And after that, now let us say data collection as the first priority. Okay. Data processing. Okay. And analytics. So you're predominantly getting into the analytics directly. And of course, you need to do a little bit of processing. And when you actually take Kaggle data, you're not doing any data collection on your own, right? But at least you can actually complete 2 tasks here, right? And in the next step, you can actually get into the data collection as well. This could be a, like say, very interesting step to take, Soumya.
Yeah, thanks a lot.
Any further questions, friends? And by the way, it is like say the political analytics or psephology is going to be one of the bigger fields going forward. And if any of you want to venture into these sort of things, you're welcome. And I'm already doing this one. And if you need any, like say, inputs or help, please let me know.
Yeah, Ajit sir have some question.
Yeah. First of all, Dr. Narayana, thank you very much. That was very nice introduction to machine learning and where all they can use matrices, because the students always think that it is just a playing with matrix abstractly, right? But here you have given a lot of applications, so that's one. Secondly, regarding this, if you do the data analytics in especially this in psychology, the one of the biggest challenge must be like mostly the data could be some kind of biasness will be there, right?
I completely
Right,
agree.
because yeah, so how does one remove that biasness?
Okay, by the way, now I'm working with UP data going for like say 2022 elections. In last 1 month, just for the data collection, my team traveled 4,000 kilometers in UP just for the data collection.
Mm-hmm.
Because we cannot believe online data as such, and we need to have our own footprint. And we have actually covered extensively in Western UP.
Correct. That's fine. That is okay. That's a collection. Even but for the collection of the data, that biasness will be there, no? Because I think, especially knowing the UP and other parts, people will always have some kind of biasness towards some party, etc. Right? So that how do you take care of those things?
Yeah, so some biasness definitely will be there. Okay, most of the time, what happens is people take data points from the relatively urban areas, and then they try to say that everything is like this.
Correct.
And we have to live with that biasness to some extent.
Mm-hmm.
Okay, and you basically have to validate with some other data points. Say, for example, after 2017 elections, there were like say 23 by-elections. I mean, by-elections actually
Right.
took place for 23 constituencies in UP, right?
Okay. Okay.
And
Yes.
now we basically have to validate our hypothesis with these by-elections, because by-elections can actually give us some idea of whether the assumptions what we are making, the inferences what we are coming up with, whether they are correct. Because by-elections you can take it as midterm exams.
Hello.
Right. Yes. Okay. Thank you very much. I think.